And we are now live. Hopefully, everything
Okay.
is working properly.
All right. Hello, everyone.
Yep.
And how are you doing today, Raf?
I'm doing all right, as usual. I have had many calls and many things to do today, so I'm a little tired. But hopefully, this will not make anything go incorrectly. So
Yeah.
yes.
It's been kind of an interesting day. We are starting to have more users of
Mm-hmm.
Contour. Like user numbers are increasing. We're doing more support, which is taking up a little bit more of my time, but it's good. I'm kind of learning some things about what's hard for people about Contour, which is good. There are some things that are a little confusing about it. One of the things that we ran into today, of course, is that you can only bind joint sockets to meshes. Um,
Right.
and it does give you errors if you have other contour transforms selected and you try to bind them. So, of course, if you select everything in a scene, for instance, that has socket in the name, you will get some errors. And it's a funny thing. I wonder how to make that kind of thing clearer to people.
Yeah, I mean, partly, and just to give people the background on this, it's sort of like we developed this, but as it goes out into the wild, and more people who aren't necessarily dedicated to rigging, in the way that I am, and are less familiar with Python, use it. Um, it reveals areas where there are things that are confusing or unclear, and there's a number of areas like that. Oh yeah, the control click one is a huge deal, right? Like
Oh, and that's another
yeah, yeah,
one. Yeah.
that's something I should have brought up on my I didn't even think of it right on our stream where we were like, oh, I'm going to bring a simple character all the way through. Is that when you want to add contour joints, you don't just click, you control click, and the reason for that is that you click to manipulate existing joints and you control click to add new ones, which is a perfectly reasonable thing to do. But because the behavior is different than the Maya uh, than the Maya behavior, people are sometimes confused by that, and so that's an example of where we just need to make things clearer to people. Um,
Yeah. Yeah. I mean, and also, I mean, it isn't even just like less familiar with Python and, I mean, less familiar with rig tools. I mean, you've been using rig
sure,
tools for years now,
right,
right? So
exactly.
pretty instinctive, and it's a new set of ideas and a new way of doing things. And it's not. It's it is an interesting question. I mean, I think rig tools works really well, but it's definitely there's a little bit of a hill to climb with it, very
Yep,
clearly for people, even very experienced people, because some of the people that we've been talking to are. It's not like they're not experienced riggers,
sure,
right? It's just it's a bunch of new stuff. So I don't know. It's something that we have to think a little bit more about on an ongoing basis, I think.
yeah. So I mean, and will that'll be certainly be an ongoing process. For today, though, as you may note, we are not looking at Contour. Actually, we're not even looking at Maya. We are looking at Unreal, because today we are going to talk about Little Bird's the plugin that we developed for Little Bird, which is also called Little Bird, which is confusing. When we originally developed this plugin, which is for real time, not stylized rendering and compositing, we we called the plugin Little Bird, and we called the other plugin that we wrote that was like a Unreal to Maya pipeline Popsicle, because the two characters in the film, people may have seen the film now. I don't really think it's much of a spoiler anyway to say that they have some names for each other. They call each other Popsicle and Little Bird. These two characters are father and daughter. Much as my daughter, when she was much smaller than she is now. I just want to make that very clear. If she sees this, she will be very upset with me if I don't make this clear. This was when she was very young. She used to call me Big Tomato, and I used to call her Carrot, 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 because when you're 6 years old, that's hilarious. This character is not 6 year old. Aaliyah is like 12, but they have pet names for each other, and so we named our plugins after that. And this was before we decided to also call it the short Little Bird. And by that time, the term had been used in so many different places, we didn't want to change it. So there's two different things. The short is called Little Bird, and as you know, I've posted on my blog, but I don't think I've mentioned it on the stream yet. You could watch Little Bird right now in Fortnite as part of Short Night and the Short Night event. Um, but Right, so there's the short, and then there's the plugin, and they're both called Little Bird, and they're two different things. Although one was used to make the other, so that's how things work. But what I'm going to show you today is basically some of the basics of how the Little Bird plugin functions, and it is actually, I think, a pretty significant advance over the way that people have typically done stylized rendering in Unreal. But at the same time, it also has a wide variety of caveats. and wouldn't be
And,
appropriate for all kinds of production.
and this was done on an Epic Mega Grant, right?
That's right. It absolutely was, and it's important to point that out too. This was an Epic Mega Grant that was basically both to make the short and the tools that we were going to use to make the short.
So they're going to be released as open source tools.
They are going to be released as open source tools. The main thing holding that back has been that with everything going on. I mean, we just released Contour. It wasn't actually, we didn't just release it, was months ago, but like we've released Contour. I'm working at TTF. I have a lot of other like I have many other obligations. Like there's just been a lot going on. But as soon as we can, and as soon as we can finish doing documentation for it, which I actually think is our primary barrier right now, as is perhaps we're very familiar with this in Notional Pipe too. Writing good documentation is actually really, really time consuming. That's one of the main things, and this is maybe a first stab at like I'm going to try to explain how this works to people who've never seen it before and don't know the context, and like that's maybe going to inform how we sort of bring it out to the world.
This is an area of UE that I have very little familiarity with, so hopefully this will be pretty educational for me too.
Sure. And I'm not even quite sure how far we're going to get. I mean, there's a lot that we could go to, and again, any of our viewers feel free to yell out in the chat comments, and we will try to address them as closely as possible. But I figure I should start off by giving like a high level view of like what is Littlebird and what is it supposed to do. And what it's supposed to do is to allow you to in real time render multiple images with different characteristics. So for instance, a pretty common thing that you would do in a conventional pipeline is you'd render a bunch of passes that would include things like maybe there'd be a color pass, there might be multiple lighting passes, there might be, depth passes, there might be various other things, and you would use them in a compositing app like Nuke to assemble your final image. And this is very commonly used to do stylized looks because it gives you a huge amount of flexibility. And because it's very hard to get a renderer to do everything you want sort of internally to the renderer. In a realistic look, I mean, people, of course, use compositing all the time in VFX when things are meant to be realistic too, right? But you don't necessarily have to get something realistic. If you give a scene with appropriately set up shaders to a brute force path tracer, what you will get out the other end is something that will be, assuming you've, set it up properly, pretty realistic. You don't necessarily have to do a bunch of things to it in post. I mean, you may want to, but you don't have to. Whereas for stylized looks, that is often not true. It's often pretty important. So the thing that's really frustrating about that, of course, is even if you are generating the passes in real time, the actual work of assembling those passes and working with them is really onerous, especially because if there's anything wrong with any of them or you need to change something, that means you have to go back to your DCC software, make some change, render out a different pass, bring it back into your compositing app. I mean, the whole thing is just sort of this ugly process that takes forever, right? And I really dislike stuff like that, right? I really, really, really want things to be real time, and I really want to be able to see what I'm doing as much as I can while I am doing it. So what Littlebird was the idea that, well, Unreal is so fast. Maybe we can make it actually render the scene multiple times, like in all of those different permutations, every single frame, and do the compositing as an actual post-process shader. And then what you end up with is that entire workflow, that entire pipeline of like I'm rendering out multiple images and I'm comping them and I'm doing various things to them in comp to combine into a final image. And I'm going to do all of that stuff fully in real time so that any change can be made to anything at any time, and you will always see a representation of your final result. And it actually worked. I mean, it took some effort to get this to work, right? This took some work for sure. It really would not have been possible if Epic was not basically putting up the money for us to explore this thing that we otherwise would not really have had the opportunity to. Like, it wasn't like a production was going to come along and let us try something this speculative. Right, this was very much something that was enabled by Epic, and we are very, very grateful for that. It really has allowed us to do things we wouldn't have been able to do otherwise. So to give you a sense of how this works, because what it means is that Littlebird does actually let you establish these different passes and composite them in real time, and it's built on top of an existing tool in Unreal called Composure. Which has some of the tools necessary to do so, but not others, we had to build some stuff on top of that. And the primary thing we had to do, and I know this preamble's been a bit long, but I feel like it's sort of important to sort of set the stage for like what I'm going to show. What we had to do was to figure out how to make it not only render the scene multiple times, which is not that hard with Unreal. Unreal has a whole way of basically kicking off separate renders of the scene, which are often used in a game. Say if you need a reflection or something, you might or render something from a different camera and use it in your final image. But it does not provide any way to change what the scene is for those different renders. And which is a problem for light passes, because you don't want any of the color information in the light pass. The entire point is it's a separate thing. And so that's what we ended up having to do a lot of work in enabling in Unreal. And it was actually all blueprints. There is no C++ code anywhere in this plugin. Blueprints can be quite powerful. So the test that I was going to use to show this is I've taken my cat, cat chasing a leaf with a sword, alembic here, and I've brought it into UE. And I actually just real quick, I need to apply the right camera, or, you won't even really be able to see it. Which I think is in Swashbuckling Cats.
This cat does a lot of work. People may be familiar with the cat from
yes.
our homepage, actually.
This is just all some stuff that got exported from Maya. Here's the camera. And this is all just sort of like standard UE stuff. I'm bringing in some stuff from FBX that has had the camera exported. Probably still works. Yeah, it does. There's no lights in the scene yet, which is why you don't see anything. Oh, and also I need to drag this back, I think, because something's not right. Got a geometry cache. It's not doing anything. I was afraid I'd have to do some kind of troubleshooting here. All right, let's try bringing that in again. That is for sure a geometry cache. Let me try re-importing it. This will take a second, and I really should have checked this before I started the stream. I'm just, this is what comes of streaming when you're also really busy. But hey, you can see the imported element, so yeah. Yeah, here's Jinx deforming cache. We can see that it is for sure an alembic, and it for sure has a bunch of data in it. I'm not going to tell it to skip empty frames. I think maybe I shouldn't have told it to do that, actually. Sampling type is per frame. Should not flatten the tracks. This will take like a couple of minutes, because one thing that is rather unfortunate about the alembic workflow in UE, which I otherwise really like, is that it can be quite slow to import. And that's something that, hopefully can be addressed sometime in the future. And I have some ideas about alternative ways of getting geocaches into UE as well. But that's a subject for another time. That's how tired I am. It's time for me to drink Red Bull at 4 o'clock in the evening.
4 o'clock in the evening, Raph, my lord.
Well, I mean, as it's not really the evening, but you know what I mean.
I don't know. I feel like, you're 10 years younger than me, but sometimes, man, sometimes.
Yeah.
Go get the early bird special.
That's right. So while we are importing our geocache, anybody have any questions? There we go. Anybody have any questions?
Well, I guess I don't know how responsive is the UE. How responsive is the UI while this is all going on?
Oh, it's done.
Okay, it's done. Okay.
What I need to do is to rewind this to like frame 100 or something. Yeah, there we go. This is what I wanted to see. Yeah, because like it starts 100 frames in, as is not uncommon for shots. Yeah, let's just kind of do something like that. All right, I mean, you get the idea, right? Let me throw a light in here so you can actually see it. Although we will get rid of this once we start adding little bird lights, which, work somewhat differently than regular UE lights. But here's a light. Here's the character. This should be 24 FPS, and I'm going to lock to display rate. Yeah, there we go. And I'm going to turn off. I should have turned off motion blur. Whatever. It's not gonna show up in the in Little Bird anyway. So here is a character. We actually are going to have to start the question of how do we use this character in Little Bird by how we actually shade it. Because one of the things that Little Bird really requires is for you to think about shading in a different way than we typically do in Unreal. So I am going to go take a look at our Little Bird content, which is going to include a bunch of things like a default shader. But actually, you know, I'm not going to use the default material because I actually want to show you how to do this from scratch. So I'm going to make a new material, and I'm going to call it cat surface. And I'm going to take this material, and I'm going to bring into it a material function. So if any of this stuff is like unfamiliar to anyone watching this, like, you know, feel free to call it out. I'm going to try to sort of explain stuff as I go along.
I mean, I wonder if you might not call out a little more what you're doing in terms of like opening parts of the interface, for instance. Like you say you're going to bring it in, but like what specifically are you doing? In terms
So
of,
I
like,
I am looking at a material here. And one of the things that continually trips me up is that shader, this isn't actually a shader in UE terms, because shaders don't mean what you think they mean anymore. Shaders are shaders are a means of calculating something now. If you're going to do something that specifically is about calculating the shading of a surface, that's a material. It's different than it used to be. I am going to tell it to use material attributes, which essentially narrows down all of those inputs into this one input, so I can plug in the result, which is a full set of material attributes that tells the surface exactly how to shade itself, from my LB material function, which has, as you can see, many, many inputs. And all of the magic that Little Bird is doing to make multipass rendering happen is happening inside this material function. At some point, I'll just show you, you know, during our discussion, maybe we'll go take a look at all of this stuff, which has many, many nested functions, and talk about how it works. But for right now, presumably, we're not doing that. We're treating it more as a user would. You may note, for instance, that unlike your standard UE materials, the Little Bird material function lets you plug in multiple different color maps. And these don't even have to be maps. They can be single individual colors. So let me actually start with that. I'm going to put down, actually, no, let me put down an actual color. That's not even the right one. There we go. That's a color. I'm just going to make it like, I don't know, some color. And I'm going to plug this into color 1. And actually, to begin with, I am not going to do anything else other than that. Then I'm going to get rid of my directional light because it will not be useful in the context of Little Bird. It's a regular light, not a Little Bird light. And I'm going to take my cat surface. Oh, one other thing. I always forget this. You do have to make sure you're using object space normals, because there are various assumptions in Little Bird that really require it. And that's really simple. Yeah.
So a Little Bird light, is that a blueprint that is based on a normal light?
Yes, it is. And we're about to add a Little Bird light, and that is precisely what it is. It is a blueprint based on a normal light. Essentially just replacing some of the features of the normal light with your Little Bird light. It's probably, yeah, there we go. It compiled a thing. This doesn't look like much, but here's what we can now do. So if it's hard to do this when you have to keep it all on one monitor. I'm gonna go to the render elements, and I'm gonna throw in an LB color, and the LB color gives me the exact color value. Now, usually it wouldn't just be one color. Usually you put like a map in here or something. And you know, I can do that. And for test purposes, I'm actually going to use some really basic map, because otherwise, you know, I'll have to assign to the various shaders and like figure out, you know, assign multiple maps, and I don't really want to do that right now. But let's throw something into that material that's other than a single color, because that'll probably make it a little more clear how this is working. I'm going to say that this texture sample parameter, or actually it's color 00 really, and I'm going to give it the parameter default of not that thing, because man, do I not want that. Let me turn on engine content where they have like a whole bunch of different. Eh. There's like some sort of nice grid or texture-based thing in here.
You don't like that one very much.
I don't like this one very much. It is famously ugly. Here we go. This looks like a. Oh, that's actually a different thing. We can't use that. It's not a. What is your problem? Oh, that was a normal map. Haha. It's like you can't do that. You're sampling a color map. Yeah, the other one is probably a cube map. And I should really have prepared myself with some actual useful texture here. Yep, that's a normal map. That's also a normal map. I just want some texture to put on here. I used to have like a nice little UV grid type thing, and then I misplaced it. I do not remember where it is. Actually, you know what? I can probably... Oh, wait, here we go. Alright, why doesn't it like that? Oh, it should be linear color. That's fine. Sorry, this is all just like UE stuff about like what type of color sampling you're doing. There we go. That should work. And it's going to compile the shader, which is going to take it a second. There we go. All right. Not maybe the best example, but you know what? It'll work. It shows you basically, essentially, these color values are precisely and identical to the color values being fed in, because this is a color pass. It has no lighting. If I wanted to add a lighting pass, I could do that after I turn off engine content, because otherwise I won't be able to find anything. Let's throw in an LB lighting. Now, if we take a look at our LB lighting pass, right now it doesn't show me anything at all. And the reason why it does not show me anything at all is that there's no lights. So I need to add a little bird light, which I can actually... Wow, see, this is what we mean when we say things are still a little bit under development. Yeah, that was a silly button to add there. Anyway, let me add a directional light. Here is a directional light. Now, here's what, which is right over here. Here's what's actually really important about this. Aside from, here, let me turn off snapping. Aside from my ability to, adjust this light and see it in real time. In and of itself, that's not terribly surprising. That's how UE does things. It's a game engine, and its great advantage is being real time, right? But here's the bit that you can't normally do in UE. These two things are being rendered off the same scene. And if I were to make them smaller, and I can scrub around in the sequencer, and they are indeed truly being rendered in real time. And if anyone doubts that, I will even move the character around, and you will see that they are truly being rendered in real time. But, despite being rendered in real time, they have entirely different characteristics as shaders. Well, I'm sorry, as materials. Because when you are using the Little Bird lighting pass, it always disregards the color information. And that's one of the big advances that Little Bird allows, albeit in a way that, does have some performance implications. And we'll probably discuss those a little bit later. So how would you actually do some compositing with Little Bird? Well, here is how one might do it. You would make yourself a shader that you're going to use as a post process. So this is a special type of shader that UE lets you make that essentially applies to an image that's already been rendered instead of being used to render a surface. And I'm going to call this lighting combine or something along those lines. And I'm going to do something real basic. You can actually do some pretty impressive stuff and complex stuff with this, because what essentially this allows me to do is to use, I'm going to change it to post process, is to use the material graph that Unreal already has with its many, many, many nodes as a node-based compositing system, more or less. And in fact, I can stack multiple post-process shaders on top of each other. So let's say what I wanted to do, and this would be a very common thing to do in a stylized context, is I've got my color, but then I want to have lighting, and I don't want to use the lighting to blend between to be additive, right? Because that's actually how rendering works in quote unquote real life. Although actually PBR rendering may be a little more complex than this, but the basic idea is what's going on internally, just your sort of classic idea of a renderer, is that each light, the color, the value from that particular light gets multiplied by the color value and then added onto the results of any other lights. That's how you get a realistic image, like more or less, right? I mean, by itself, that won't really produce a realistic image, but it's sort of a fundamental aspect of how most renderers work. We don't want to do that. We want to use this lighting pass to blend between two different images. This would be much more of a stylized thing, and the kind of thing that is normally quite difficult to do inside the context of a shader. Because you don't really have access, usually, to the light information as a value, right? That's something being done internally to the renderer. But we do have access to that because we're rendering these two different passes. So here's what I'm going to do. I'm going to make a texture input. This is going to be a texture parameter. And I'm going to call this one A. And I'm going to make another one. I'm going to call this one B. And I am going to then have yet another pass. I'm going to call this one, what am I going to call it? I'm going to call it blend, I guess, or something. I mean, you could call it blend, you could call it alpha, you could call it whatever. And I'm going to take the red channel off blend, and I'm going to use it to do a lerp, because we were talking about how, like, you can use any of these nodes that UE has available, I mean, including linear interpolate. Pretty normal thing. I'll put those two in as linear interpolate. And I'm going to take the red channel off of blend, the blend thing, and I'm going to do that. Now, there's one more thing I need to do before this can actually be useful, which is I need to add something that's going to allow me to darken one of these, or maybe both of them. And the reason why I need that is because in this particular case, I mean, I could render two different color passes and put these in here. And maybe I should, actually, because I think that maybe explains how this works even better. Yeah, that is what I'm going to do. Okay, so I'm going to save this, but I'm not going to use it just yet. I'm going to actually do two different color passes, because I think that gets across the idea of what Little Bird is for, even more so. So in this case, I have my color 00. I'm now going to have a different version of this. This one's going to be called color 01. And I'm going to do my modification of that right here. But it could, of course, be a completely different map, and in many cases it might be. You might, in this kind of stylized rendering, if you think of something that's like an arcane-like look, for instance, you might well do something where you have a different map painted, a different texture, for the dark areas of the image, like the dark side of the shaded character, and it might be a different image from the bright side, which is how you can get a lot of like very effective painterly effects. So in this case, I'm merely going to darken it right here. I'm just going to put a multiply in here. I think I can do with them. Yeah, that works. I'm going to multiply it. Actually, I'm not even gonna multiply it by a single value. We're going to be able to put like anything we want in here. I'm actually going to make it a parameter, vector parameter, and I'm going to say color 01 tint, and I'm going to tint it. Say, in addition to making it darker, I'm also going to tint it kind of blue. And I'm going to plug that into color 01. And once again, it'll take a second to compile those shaders, because it does. And now, so we have LB color, which looks the same as it did. LB lighting, nothing's changed. But if I go into these render elements, and I pull in another LB color, and I change its color from color 00 to color 01, now we are looking at a different color map. And it's this ability to have arbitrary maps that can look like whatever you need them to look like for your compositing purposes that really makes this tool work. And that makes it capable of doing all the things that it can do. And this is how everything worked with Little Bird, right? We'd have, her shaders were set up to sort of display things in different ways, depending on what we needed. We had a light version, we had a dark version, we had some things that were specialized for like her eyes. We had a variety of passes that we just used in comp to build up the final image. So here we've got lighting. Let's combine these now using our thing here. So using the post-process shader we just made. So note this composure window over here. So anyone who is unfamiliar with it, composure is a system for compositing in Unreal. And what Composure does, among other things, it actually has a whole bunch of different capabilities, we're only using part of it here, is that it allows you to establish these passes that can, among other things, render, I'm going to turn this off, render various parts of the scene. So, and that's the primary thing we're using Composure here for. We do also, however, have an LB composite Composure element. And this is not intended to ever render the scene. It is instead intended to be used to have essentially a stack of post-process shaders on that can pull in the image of anything that's beneath it in this hierarchy. That's how Composure works. So if I go into LB Composite now, and I add a new transform pass, and that's what they call it. Like, they mean it it's essentially something that transforms the data of the original image through some compositing post-processing. It's a bit strange because the term transform is like very overloaded in CG, but it is what it is. And I'm going to put my lighting combine in there, which currently shows this like super ugly texture. And I'm going to say that A is going to be LB color, B is going to be LB color 2, and in order to blend between them, I'm going to use LB lighting. I was actually sort of imagining it being the other way around. So I'm going to make this one color 2, and this one color. There we go. I feel like that's a little bit more visible. And we could, for instance, do things in a very different way, where we're doing very different results for these different colors. So as an example, let me go to my cat surface, and instead of plugging in color 00 to this, I'm going to get rid of this, and I am going to plug in just like a completely standard, like a single color. So I'm going to make it like, I don't know, some color or other. And I'm going to plug that into color 00. And after it finishes compiling shaders, there we go. So here's an interesting thing that's very, very useful for stylized looks. The area of the image that's showing up in the lighting has an entirely different texture than the area that's showing up in the dark area. Those bands and stuff are completely missing in the lighting. And so that's
really neat.
Yeah,
that's really neat. I'm going to say that's very cool.
It's a thing that like, if you don't have some kind of compositing, it's really, really hard to do that. Like, if you wanted to get up to your elbows, and people have, like, if you want to get up to your elbows in, Unreal's shading models, you can code Unreal, essentially recode it to do stuff like this. But it's very, very difficult because you are essentially rewriting how Unreal's renderer works, because it is not designed to do this, right?
So the performance implications of this mean that probably you wouldn't do this in an actual game.
No, you could not do this in an actual game. Let me show you actually what the FPS is. Now, this FPS is quite nice. Look, we're getting 120 FPS. So you might look at this and say, oh, the performance implications, like, whatever, this doesn't seem that bad. It is if you start adding more stuff, though. Because the problem that we're encountering here, it's fine if you've got like one character, and it's just that one character. It's no problem. You're not going to run into any performance issues. But the issue that we do encounter with performance here is the more stuff you add, it goes up exponentially. And the reason why it goes up exponentially is you're not only increasing the amount of time each render takes to make, because it is literally like every frame, like every time it goes to render, it is rendering all 4 of these things every time, plus the viewport. Right? And so not only does the render get slower if you add a bunch more geometry and stuff to it, of course, but you also are doing that multiple times. And so in a complex scene, you'd probably be both adding, you'd probably be increasing scene geometric complexity, but then you'd also probably be increasing the number of elements that you need for your comp. And so the types of things that work really well with Little Bird are things like Little Bird the Short, where you've got scenes that don't have a lot of geometric complexity. And the degree to which that's true of the Little Bird Short might not actually be clear, because it's got like big backgrounds and spaceships and stuff. But all that stuff is projected paintings. It's not ever like we did model out some of that stuff, but it's all made out of like cubes, and like it's very simple, and like it doesn't have a huge amount of complexity, because its purpose was to be like some stuff that you'd project paintings on, and the look and the feel all just comes from Jill's paintings. That's Jill Daniels, the art director. And you know, it's worth noting about Little Bird and about what these kinds of tools, and it should be said also the ephemeral tools, allow. The entire Little Bird short, which is like, you know, almost 3 minutes long and, you know, has some complicated scenes in it, right? That entire short was made, like, in primary production was literally 3 people, right? There was Chris, who was the director, and he, you know, he was doing editing, he was doing layout, he was like choosing shots and doing a lot of the work of like setting things up and, you know, sort of putting together the background geometry and, you know, figuring out how the piece should feel. Like he was, you know, sort of its author really in a real direct way. I was doing tools development and rigging and animation. And Jill was doing like all the art direction and painted every single background. And we're not the only people who worked on the film, of course. Like, you know, Carol Cornells was our modeler, and like there were people working on sound. I mean, there's like plenty of other people who worked on it, right? I'm not saying we're the only ones, but in terms of like who did like the primary production of this film, like, yeah, I mean, it was 3 people, and was pretty much facilitated by the fact that you could do stuff like this purely in real time in this way where just the amount of work that you have to do to get this working is so drastically less than it would be in a conventional pipeline. I mean, we had a pipeline, but it's very rudimentary compared to what a big studio needs to be able to sort of push this huge volume of data and this huge volume of information around between different packages. And we didn't have as much of an issue with that. Yeah.
I mean, I think we've said this before on the stream, but, you know, we're pretty bullish on the idea of this real-time stuff. And if there's a little bit of an impedance mismatch in terms of like, it was designed as a game engine, right? So some stuff in terms of doing real-time production doesn't quite fit yet. But I think it's pretty clear that this is something they're interested in too,
absolutely. Right?
So
yeah,
it seems like it's coming, right? It seems like it's definitely something that is going to continue to evolve over the next few years.
I mean, I absolutely think that it is, and I mean, Epic clearly sees that this is an important thing, right? You know, like they're really pushing into linear production very strongly, and I think that more and more companies are seeing the benefits of that. I do think that like the days outside of some very specific VFX contexts where absolute realism is like really essential, right? But I would say that for most animation production, the days of offline rendering are really numbered. Real time is just it's such an enormous advantage. It's really hard to overstate it. But then again, you have the problem of like, well, it's not really designed to do stuff like this, for instance, right? And so that's part of what we're working on. And in this case, I should say, usually when I'm on the stream and I say we, I mean Notional Pipe. In this case, it means, you know, basically like me and Chris and our little, you know, sort of mega grant funded like efforts, right? You know, it's not really like the same thing in the sense that it's not really going to get the same kind of ongoing development that any of the Notional Pipe stuff is, because, you know, it's not a commercial product. It's something that Epic paid us through a mega grant, and, you know, we want to make it available to everyone. But, you know, unlike Contour and the ephemeral system, we're not going to continue a lot more development on that in the future. Yeah.
No, but I think it is likely that Notional Pipe, when we have the opportunity, which could be a little while, but I could see us doing a lot of stuff related to you.
Oh, absolutely.
I think that's in the future.
I do too. Like, I mean, it's not probably going to shock anybody that we would love to do Contour for UE, right? Like, you know, that's something that we hope can happen, and I can't really say if it will or won't at this point in time, but it's for sure something we want to do, you know? So let me show you a few other of the things that you can do with this, actually. I want to just sort of like, because I don't know if this is like a very simple example, and there's a few things I could do to it. Oh, I didn't mean to open Cat Surface. I meant to open the Lighting Combine post-process shader. There's a few other things I could do to this to make it clear sort of what some of the advantages are. So for instance, let me take my blend, which I have the lighting input on, and I'm going to do a clamp. Again, I have access to like all of these many nodes. Oh wait, no, I don't want to clamp, I want to remap. Yeah, I think remap value range is the one. The many nodes that Epic has developed for use in shaders in Unreal, and they're all accessible here. So I'm going to I'm going to put this as the input, and then I'm going to say, I'm going to have the ability, essentially this is how I can do a two-tone, right? I can say, I guess I do want a constant. I want to say the input, you know, we're remapping 1, 0, and 1. So that's our input low and input high. But then we're going to have the ability to remap that in different ways to to target low and target high. So I'm going to make this a parameter, scalar parameter, and I'm going to call that fall off 1. Say that's like the beginning of the range. I don't know, like you might name these something different. It doesn't really matter. This is just for demonstration purposes. And I'm going to say that both of these have a max of 1. If you cross them, you'll get weird results. Don't cross the streams. And then I'm going to output it, and I'm also going to use a saturate node. Now, saturate does not mean the thing you think it means. You're probably thinking it means color saturation. That's not actually what it means. It's actually a clamp that clamps things at 1 and 0. There's a math reason why it's called that, but I don't remember what it is. So anyway, nothing changed because I set that up specifically, so nothing would necessarily have to change. But let me go to my composite, and now I have these material parameters that I've exposed. So if I start doing this, that did not do what I expected it to do.
I should mention that your portrait is kind of a little bit over that.
Oh, is it over this region? Yeah, let me go adjust that in Bob's. Yeah, that's probably a little better. That's a good point. Anyway, this did not actually have the effect that I intended, and I just need to go take a look at why that is, because I would have thought that instead of just darkening this would actually crunch it in. Like, it would basically be like a two-tone, but that did not actually work the way I had expected. Why didn't it do what I thought? See, now we're getting into, like, oh, this is all nice and clean until, of course, it doesn't do what you expect, and then you got to figure it out. Yeah, I would have thought that would have worked. It's been a while since I set this up. 1 second. Maybe the saturate node isn't the right thing. Let's see if I just cut it out. It's probably not going to change anything. I just want to make sure I understand what's going on. Yeah, no. Still did not do what I would have expected. Oh, I'm an idiot. I did this the wrong way around. I'm taking these things and mapping them to 0 and 1, not the other way around. Now let's see if this actually does what I think it should do. Yes, that's what I was expecting to see.
Yeah, it's that not making mistakes thing we were talking about.
I know. It's just like, oh, this all works great if you don't make mistakes. But note that this now gives me a way of crunching it in as a two-tone. Now, anyone who is familiar with UE is probably familiar with the fact that UE does not provide any way of manipulating light like this, out of the box. Usually when you have games that have a toon look, or productions of various kinds, somebody has, again, had to get up to their elbows in the UE shading models in order to actually change how the renderer functions, in order to do stuff like this. But even if it were true that even if it were true that it did offer this functionality out of the box, you'd still have a bunch of advantages of doing things in this way, in that you have a huge amount of control of exactly how it works, right? And this is actually one of the ways that doing stuff in Unreal really pleasantly, in my view, has a lot of advantages over doing this kind of thing in Nuke or After Effects. And a lot of disadvantages too, right? I mean, one of the main disadvantages of not doing it in a real compositing application is there's plenty of features of a real compositing application that aren't ever really going to be a thing in Unreal, like masks and stuff that are in 2D. Like, there's not really going to be a way of doing that. Do you really need that? You may or may not. It depends on the shot, right? Or depends on like what you needed to do. We mostly didn't need it for Little Bird. We didn't have a problem, of not needing that. Depends on what you're doing. The other thing though is if you use like an After Effects filter or a Nuke node or any of those things, I mean, you can make your own. That's really kind of strangely difficult in After Effects. It's a little easier in Nuke. I mean, they have Blink script and stuff. But nevertheless, it's kind of a big production if you're mainly using what they've made. Here, I'm basically bespoke creating whatever I need, right, for my particular production. And what I would actually do, I mean, I wouldn't remake this graph. Not that it's particularly complicated, but I wouldn't remake this graph like every time if I was doing a real production. I'd have a library of them, right? But I'd have a library of them that would do whatever I specifically needed for this specific production, with the ability to sort of go in and mess around with this in a way that's, you know, pretty understandable to a lot of artists, right? I mean, you could do a lot of stuff in Nuke with Blink script or something, but you do kind of need to be a programmer to do it, really. You know, it's not really meant to be something that's very accessible to artists. This kind of is, and while I have my doubts about the use of visual programming languages sort of in the general case, this is, for this kind of thing, it's basically perfect. It's very easy to understand what's going on here, right? And even if it were a bit more complex than this, it wouldn't be too hard to keep this graph an understandable thing, because it's all forward, right? It's a forward graph. Everything just goes from the extremities into this central point. And that's the kind of thing that I think visual programming works very nicely for, because it's something that is clearly, you can lay it out clearly in a visual way. And
I mean, I feel like there's no doubt.
Yeah,
there's no doubt that a lot of stuff is actually quite amenable to visual programming, if you ask me. I mean, look at spreadsheets, right? Sure. Spreadsheets are basically visual programming, and you know, spreadsheets are really powerful. It's just that you shouldn't try to do everything in a spreadsheet.
Right. You definitely shouldn't. So let's look at another way that you can use this system, because the other thing that this offers you is the ability to do things that analyze the whole image. You don't need, and I mean, an example of something that would analyze the whole image would be something like a blur, right? You can't really blur things inside a renderer while it's rendering. That you can't do it, because in order to blur something, you need to know what adjacent pixels are. And while something is being rendered, you can't know what the other pixels are. like that's the whole point. Is even if you're doing it on a CPU, you're definitely doing it in parallel, because otherwise rendering would take 10,000 years, right? I mean, you know, the way it used to be. So and even then you'd be missing some of your data because you'd have pixels that hadn't been rendered yet. So you can never know what other pixels look like while you're rendering, but you can certainly know it after the fact. So here's an example of something that we did like really extensively on Little Bird, actually, which is to use fake rims. One of the problems that we encountered in Little Bird, basically, like one of the things that we encountered as we were doing our look dev and like trying to figure out what it was going to look like, is that all this stuff that Jill would paint would have these nice regular rims to it. Like she'd paint this really painterly stuff, and to give the character like its edge, she'd paint in a rim, and the rim didn't look like something that had actual lighting. Because when you're creating a stylized look, something that feels like actual lighting may be the completely wrong thing. Like something that you paint in as a rim is going to be more regular and more sort of fit to the character's shape, and more just sort of expressive of its shape on screen, in a way that your other stuff that you're rendering, I mean, you're like your actual calculation of fall off of light is never really going to produce. So one of the things that we were able to do is to use this system to go and create a bunch of sort of fake lighting tools of various kinds. And so I'm going to put a fake rim on here. So and it's actually a toon line. I mean, that's another thing you can do once you see the whole image. You can do things like you can do edge detection, right? Once you can analyze the image as a whole. So here's what I would do for this. Let's see. I am going to, first of all, I'm going to throw in a depth element. And that's going to look like nothing at all, because the depth that this is using actual values. So, Unreal stores values as 32-bit float, which means that they are not bounded to 0 and 1, right? They can be any arbitrary value. And so the depth value is that thing's actual distance from the camera. Well, that's not actually quite true. It's its actual distance along the camera's forward vector, because Unreal kind of cheats and doesn't use real depth. But that's like an implementation detail, really. But the point is, it's like the number, the value on this pixel is the actual distance of the pixel being rendered. And therefore, it's some very large value, much larger than 1, and so they can't really display it, right? If I wanted to be able to see what this depth was actually doing, I actually think I added a thing here. Yeah, I added a depth divide thing here so you could tweak it. So you could sort of see what you were doing. And if you turn up your depth division to like, Oh, maybe there we go. Maybe 1,000. You can actually see the depth. And so if I was doing like fog, I might actually do this and play around with it until I got like depth values that looked good for my actual image, right? But for this, we don't care, right? We
So,
need the actual values.
so can I break in here, Raf,
Sure.
and just ask, is there a reason that you're kind of taking that approach with it instead of, say, normalizing it into some space, like a forward and a backward plane, and normalizing that into 0 to 1 there?
Essentially, because there's not. I mean, you could. That's totally a viable thing to do, and you could set that up because, well, so first of all, the depth that Unreal renders by default, of course, does not do that, right? And so it's the question of like, well, how are you going to set that up? And it's totally a thing you could set up. But the other thing is, there's not really a good reason to do that when you're going to use depth the way that I'm about to use it. Because
Okay.
you often need to know the actual distance of things. I mean, in this
All
particular
right.
case, it's not actually that important that you do know the actual distance of things. But in a lot of cases, it is. So, for instance, if you want to vary something by how far away it is, knowing the actual depth distance and having that be like actual real world values is helpful. So that's the default, and you can of course screw around with it any way you want. In comp, you can normalize that depth to whatever makes sense, right?
Okay.
But
I'll
for
also mention that we have a comment on the stream.
let me take a look.
While we have a moment here, which is Steph Devs is saying, hi, I just came across your blog today while taking a break from rigging. I like the look of your work so far. It's crazy to me that more people aren't talking about rigs as programs, but I'm a programmer first. Go figure. Now it
Yep.
says hola. I'm saying hola.
Yes, it is. I mean, actually, it is kind of crazy, right? Like, I mean, not that this isn't a rant that I haven't made on many, many, many occasions, but it's like, uh, you know, I mean, this is part of the pathology of rigging, right? It's the pathology of rigging technique that we don't think about it that way, and when you do think about it that way, a lot of rigging problems go away. Not by any means all of them, but a bunch of them, and you're speaking my language here. Like, I really wish people saw it that way more often, and were more willing to delve into that side of things. I've talked before about how I think part of the pathology of rigging is, yeah, exactly. Steph Dev says my natural inclination is just go write the rig in a real language. Well, yeah, basically, like, there's no reason you couldn't do that, and in theory, and if you had like a good framework or a good, maybe framework is long term, but like if you had a good library for that, I think that it would be vastly faster to develop rigs that way than the way that we normally do it. Yeah.
Yeah, I mean, I think for me, because I'm very much, I mean, I'm very much a programmer, not even a programmer first, but I'm a programmer, not a rigger, because I'm not a rigger. So I definitely think about it that way. And one of the things that really occurred to me when I started taking a close look at how people rig and how RAF rigs is that it's very clear that people are programming when they're rigging, but they're missing a lot of the tools for abstraction that
Yep.
we take kind of for granted as programmers. And it'd probably get a lot easier if some of those tools were there.
It would. I mean, again, I'm just repeating myself now, but yeah, this is a serious issue with rigging, and I wish more people understood that rigging is essentially programming, and that the cognitive tools associated with programming can be used to make rigging much simpler. Um, Anyway, where was I? Right. So I've got depth. I guess I'm going to use my same lighting pass here. I mean, you could make multiple lighting passes, like whatever, it doesn't matter. But I'll just use the same one. I need to put it underneath LB Composite because keep in mind that there's this hierarchy to composure elements, and that means that LB Composite only has access to things that are underneath it. And that's just a thing to keep in mind. That means that you probably shouldn't have. I mean, here's something very similar to rigging. Don't have a big complicated hierarchy, right? If you have like a whole bunch of nested stuff in here, you'll inevitably, some layer will need to some pass some you can have subcomposites and stuff in here too, but something will need to reference something else that it can't get access to because the hierarchy doesn't allow it, and then you're just like, it's just going to be a nightmare. So the way I typically do it is that I do all of my sort of compositing on this one LB composite, and then every other thing that's underneath it is just like on this one level of the hierarchy, and that way you don't get into that situation where you end up backing yourself into a corner. So let's see, taking a look at LB Composite, that's right, I am going to make myself another post process. So this one is going to be called, what are you doing, UE? Like, seriously, what are you doing? Wow. I'm right clicking and it's like, all right, I don't know. Anyway, I'm going to make another post-process material, and I'm going to call this fake rim. Similarly, I need to make this be... Yeah, see, it's doing something really weird with... Yeah, I'm going to restart UE. All right, let's try that again. No, I don't want to open up my asset editors. I just want to open my level. I don't want to open my test sequence. And we should see that everything is back in place. If we move to LB composite, here's our composite, right? Now here's one area, I just want to point this out because it is something that sometimes surprises people about Littlebird, which is the fact, and this is something you can't really get away from. What you see in the viewport does not bear any resemblance to what's in the composite. I mean, it's not quite true. It's not any resemblance, but it doesn't really look like it's never going to look like what's on the composite. And people do have the idea, and I agree that this would be appropriate if this was how it worked, that you should be able to like fly around and see your lighting from any angle. But this workflow really does sort of like lock you into, this is my image, right? And I'm working with that image. So it's just a thing to keep in mind. That's an assumption that people tend to have with UE that is, you know, not true in this case. So let's see, where was I? Right, I was making this fake rim shader. And I'm going to tell this to be a post-process shader. And I'm going to say the shading model, oh right, it doesn't matter because it's a post-process shader. I'm going to take in a couple of things. Right, I'm going to say, let me actually start by figuring out what it needs. So here's our post-process building blocks. This is something that is not really exactly part of the Littlebird system, but ships with Littlebird, as it were, if Littlebird shipped, which it doesn't, which is a bunch of post-process material functions that we've made that are really helpful in a variety of ways. And what we're going to use here is the LB edge detect. And it's going to take in an image to do edge detection on, which we're going to use our depth. But note something about this. See where it's got a little letter next to all of these things? So threshold and offset magnitude are S, which means they're scalar. Image is T2D, which means, it means that it's a 2D texture. That's not the same thing as a texture parameter that we've been using previously. What that does is that it samples the texture and passes along to the rest of the graph just the color value that's been sampled at a particular UV. We need to pass in the whole thing because the LB edge detect needs to be able to choose to look into that image anywhere it needs to be able to do the edge detection. If you see what I mean, because you think about it, it's like, oh, I want to find out if this particular pixel should be black or white. I need to look at neighboring pixels. That's what edge detection is. So in that case, instead of my usual texture parameter, I need a texture. That's a texture sample parameter. I need a texture object parameter, and I'm going to call this depth. Depth isn't the only option here. I mean, you could use other things. You could probably use normals. I mean, there's a variety of things you could use. But depth has worked very well for us in the past. On offset magnitude, we're going to just make some scalar parameters. And we're going to call that... I'm just going to call it strength, which I actually think is maybe a better term than offset magnitude. I'm going to default it to 1. And I'm going to do, for threshold... I don't know what the default for that should be, but yeah, we'll just play around with it because we can do that because it's real time. Nope. There we go. Wow, suddenly I can't spell threshold. I'm gonna set it to 0 by default. It's probably gonna look terrible, but you know we can play around with it because everything's real time. So here's our fake rim. We have, oh, right. Well, we also need this other really important bit. This gives us a fake rim, but it doesn't do anything with it. Actually, let's do that first. And then we'll amend this. So let's throw our fake rim on there. LB composite. We're going to add a new transform pass. Oh, it does this thing where it calls it transform pass 0 again. It's like a weird little bug. There we go. We're going to throw in our, I'll just save all fake rim. We're going to tell it that its depth is LB depth. And we're going to get a weird looking result for a variety of reasons. One of them is threshold was like totally weird. All right, that's what you want, right? So this is like kind of a cheap tune line. Like it's really basic edge detection. I think it's Laplacian edge detection, or I'm mixing up my math terms possibly. Anyway, it's not Sobel. It's simple. It's a bit simpler than Sobel, but it's edge detection. That's all that's really going on. And what strength does is increases the thickness of the line, as it were. And what threshold does is to change where the lines appear. If you think about it, so it's looking at nearby pixels, and it says, I ignore you if you're a certain, or rather, if you're under the threshold, so you're similar to me in terms of depth, I'm going to ignore you. But if you're pretty far away from me over the threshold, I guess that I don't ignore you, and then I must be at an edge, and I'm going to get colored white, right? And then strength tells you how far away it's looking, so it essentially controls the thickness of the line. So this is like a really simple, basic tune line, kind of. Not a particularly good one. I wouldn't really use this as a tune line, but it's very good for this effect. So now what we need to do is to change that so that it changes depending on the lighting. Now, note one thing, actually, I should note here. One thing that is a little bit of a like break on your productivity. It's not that significant, but you do often have to recompile shaders. This one's really fast, so it recompiles more or less instantaneously. But the really nice thing is when you've set up a bunch of these things, and then like when I was playing around with all this stuff, like this is all purely real time. They're just parameters. Nothing requires any recompile. So typically speaking, what you're doing in a shot is you've set up a bunch of things that are what you want, and then you just throw them on and you adjust parameters and stuff. So anyway, we need to modulate this strength value using the light. So this is actually kind of a cool trick. So this one is going to be a texture sample parameter, and we're going to call it light, but without the slash. That was, I'm surprised it even let me do that. Seems wrong. I guess it'll let you put anything in a string, in that string, but whatever. And we're going to multiply so that the strength goes down to 0 except where the light actually appears. So the first thing that'll happen is not much, because there isn't actually anything going into this light. Let's put LB lighting in there. And here's where our fake rim becomes more like a rim. Essentially, I'm controlling the thickness of the line using lighting. And again, this is sort of like the amount of freedom that you get with this. I mean, Nuke, for instance, is exceedingly powerful, right? Nuke is an extremely powerful application, which is why people use it constantly, even though it's ridiculously expensive. But doing stuff like this, where you're sort of changing a parameter by sort of modulating a parameter by some arbitrary thing, isn't actually easy to do in Nuke, as it turns out. It's the sort of thing, Nuke can do all kinds of things you will never do, right? But it does also mean that you just have a lot of control over exactly how you're going to do things in a way that isn't really that hard to understand or that complicated. And that's why we've kind of like left it up to the user. Like, well, you can just build up whatever you want in terms of compositing. So now we have, here's our fake rim. Here's me trying to fit all of this onto one monitor. And the nice thing about this fake rim is that it looks kind of like a rim, but it's just really, really regular, right? Like no actual light is ever going to look this regular and sort of like nice. And we can, play with the strength, which is like, which can let us get like kind of a thick like rim-like thing. I mean, it kind of went too far there, But all of that is playable with in real time. And now we got to add that on top of whatever we have behind it, or it's not going to do anything all that useful, right? So, let's see. I'm going to go in here, and then I'm going to have another input. And I'm going to call this one prepass, which is actually what you... No, I wanted to type in there. Which is what UE calls it when you're taking sort of the results of the last post-process shader in the line, as it were. No, not multiply. We want to, actually, in this case, I think we want to add. We're going to add the results of this to results of that. Plug this into emissive color. Let's see if it automatically, yeah, it automatically filled that in, because when you call something prepass, it automatically fills it in with prepass. Prepass just means whatever was behind it in the line of post-process shaders to be evaluated. So now we have a nice fake rim. And like, just to show what that looks like with it off, here's off, here's on. And I mean, there's other stuff you'd probably want to do to this. Like, you probably don't want it on her teeth or something. And you could have another map, right, that would like modulate that if you wanted to like explicitly keep it off some areas of her body or something. Like, it's all about that kind of trickery over trying to make everything work like a you know, as a model that's going to apply to everything. I mean, that's what you do with realistic rendering. Like, you do some kind of, to various degrees of accuracy, you have a simulation of real light. But what we have here, we don't want a simulation of real light. We want to think about this more like a painter. Being like, what do we need for this image to make it read well? And then be able to specifically go and do specific things to it, right? That only affect certain things. Maybe in some, you want the strength to be totally different. Like, you want a big rim in one shot and a little tiny one in another shot, and you just play around with stuff until it looks like what you want it to look like. And you just build up the image as you need. So let's see. So I have to leave a little bit before 5:30 today. And there's plenty of other features of Little Bird that we could look at. And I don't think we're going to get to you know, all the things it can do today, but maybe this gets something across. But there is something else I wanted to show, which is how it handles anti-aliasing, which is actually something I'm rather proud of. So the image that we're doing right here is totally un-anti-aliased, and there's a reason for that. There's actually multiple reasons for that. One is Unreal's natural anti-aliasing, whether you're doing TAA or FXAA or one of the other anti-aliasing methods that has you know, possibilities, doesn't actually work that well. It's good enough for a game, but we had really significant issues with TAA actually, because it's not deterministic, right? TAA will look a little different depending on what direction you scrubbed from, say, because it relies on previous buffered frames in order to try to produce its effect. That's temporal anti-aliasing for anyone who is not aware. And FXAA, which is fast approximate anti-aliasing, I think, is, you know, it's way better than nothing. Like, it's good to have that in a game when you don't really have any other option, but it's not really sufficient for the kind of smoothness that we want for something like this. And so the way we ended up having to deal with that on Little Bird itself was that we did this really unfortunate thing, which is we would use TAA or FXAA in order to get some anti-aliasing, even if it wasn't quite what we needed. But we'd also render at 4K and reduce afterwards, which is, frankly, just a really ugly way of handling it, right? You know, you really don't want to have to do that. So I ended up, subsequent to the, you know, Little Bird being finished, and, you know, with further Mega Grant assistance, doing some work to develop an entirely different method that allows you to both do really nice anti-aliasing, but also, you can both do really nice anti-aliasing, but you can also do transparency with it and a bunch of other nice things. And what this technique actually is an ancient technique from the dawn of time. The first application I saw do this was Lightwave 5, and this was in the 90s. This was back before people understood how to actually render stuff properly, right? Oh, it looks like we have some comments. So before I go on to the rest of that, I'm going to answer.
Yeah, I was waiting. Yep. I was waiting for
who says this is a contour question, but I'm happy to answer that. You know, sort of like take a momentary break from this and answer that. Could you use contour bones to drive third-party plugins? My friend showed me Ziva, but said you need to drive it by joints. So the short answer to that is yes. You wouldn't probably use the contour joints themselves to drive it. You would use them to drive joints, right? So that's a scenario where you'd probably use and we have one of our videos on that. You'd probably use the spline constraint to attach some regular joints to it. I don't know exactly what Ziva uses the joints for, but it probably does need inputs that are actually transforms and not a spline. That would be very normal. So yeah, I mean, you drive some transforms with it. So the short answer is yes, you would have to do a little bit of extra work to add some transforms or whatever it is that Ziva needs. Steph Dev says, very nice. This tempts me to look at doing similar effects in my game project, but even more, it makes me want to achieve fluid animation. Well, We are all about fluid animation, so keep coming to these, and we're going to be talking about that soon, I think. And yeah, I mean, I do think that doing similar effects in a game is actually a significantly more difficult problem. Um, because because you can't do stuff like this, right? You can't render the scene multiple times in a game. It's going to be way too much of a performance hit. You probably will need to get up to your elbows in the Unreal shading models, and that's something that I have seen people do. It's possible to do it. It's very, very difficult. That's been my understanding. And the people who I have worked with who've done that have met with somewhat limited success. So unfortunately, it's really tricky to figure out how to do it in a truly like real-time interactive environment, as opposed to what I'm doing here, which is a cheat, right? That works fine for works fine for linear production, at least some linear productions, but you probably can't use it in a game.
I would be kind of surprised though if UE weren't. I mean, if Epic weren't kind of taking a look at this point.
Oh,
right?
I
expect that this is going to get easier as time goes on.
I would not be the least bit surprised. They may well be developing things along these lines, and they may be developing things to open up their render pipeline too. I mean, I don't know if this is true. I'm just guessing, right? I mean, they might be, right. But it wouldn't be. I would think it would be pretty not very surprising if they were. Working on things to sort of open that up to be a little bit more scriptable, much as Unity has done. So anyway.
Also, I'm gonna put a link to the video about driving traditional stuff. I'm gonna put that in chat. So that's like a short video we made that just demonstrates how to drive Maya joints with Contour. So you can use that for export to a game engine, but that would also work to do something like drive a plugin that relied on Maya joints or other transforms.
Yep. So to answer Eugene Flormata. Hey Raf, you try MSAA or UE5's TSR. So MSAA did not work. So I should be noted, actually, I totally forgot to mention this. We actually are using the forward shading model here. So we theoretically could use MSAA. And the reason why we're doing that is essentially for speed, because if you have to do a very large number of renders, as we do here, with a low number of lights, it's actually going to be faster than deferred shading. But MSAA did not really give us what we needed because of the so. I'd have to get into how MSAA works. I think I might skip over that just because we're running a little low on time. Basically, the problem is MSAA is very good at anti-aliasing geometry edges and not very good at anti-aliasing a variety of other things because of the nature of how it works. As for UA's TSR, I'm not actually quite sure what you mean by TSR, so you might have to sort of clarify that a little bit. But once you do, I will do my best to answer. Anyway, so here's how we are handling it. So, this is ancient of days, although it is something that I actually suspect UB does in other circumstances.
It is temporal super resolution.
Temporal super resolution.
According to search engines.
Yes. So that is something actually that we sort of discussed a bit, which is to say there are actually a bunch of algorithms out there. As you're saying, right. They did do that for Lumen and Nana. Yep. There are a bunch of algorithms out there that are essentially using machine learning to do a combination of upsampling and anti-aliasing. And for us, part of so there's a couple of issues with that. And one of which is that because it is temporal, it suffers from a lot of, I think it is probably generally superior to TAA, right? Among other things, it does a bunch of stuff that TAA doesn't do, like upsampling. But it is still temporal, meaning it depends on previous images that are sort of left in the buffer. And we want things to be purely deterministic. We want to be like, when you go to a frame, does not matter where you just came from. You go to a particular frame, you will always see the same image. That's something that's very important to me. So those are very cool technologies for sure, and it may be that they end up being usable. I never really experimented with them, but it was always something that after my experience with TA, I was a little leery of. So what I ended up doing instead was to do an accumulation buffer. So watch this. So I'll open up the LB composite, and I will tell it to have 6 subdivisions and accumulate a frame. And if we zoom in on the image that it showed here, that is an anti-aliased image. Now we're zooming way in, so you are seeing like some of these little dots at the edge. But that would be much worse. Otherwise, if we want to smooth that out, we can turn up our number of samples quite a bit. Let me turn it up to 8. How much does 8 give us? Well, it gives us 8 times 8, so 64. Accumulate frame. And that starts to get a little nicer. You can go all, I mean, it's very, very thin, which is why it's still kind of like a little bit on anti-alias there. You can go even further than that and go into, how much do I let you turn this up? Okay, I'm going to turn it up all the way. That's going to take a while. Yeah, see, that's never really going to go away because it's so thin that it just can't figure it out. But that was also like way zoomed in. But basically what's going on here is that this is something that's very equivalent to multi-sample anti-aliasing. Like your usual thing. Like your usual thing with a normal renderer, right, with a ray tracer or something, is you shoot multiple rays per pixel, and they're in slightly different positions, and that gives you your thing. Because the problem with anti-aliasing, right, is that you've got some polygon, and your pixel's a square, and part of that square really is one thing, and part of it's another thing. But if you just sample at the middle of the pixel, you don't know that, right? Your whole pixel is one color value, and that's what aliasing is, right? So somehow anti-aliasing, if it's not just a trick like a post process like FXAA, anti-aliasing has to find out what other data is in that square pixel region, so it can average it to produce anti-aliasing. And you can see this looks very nice, like around her ears or something, or like, you know, on this area, like this is very, very nice smooth anti-aliasing, including of fairly thin things like her whiskers. But not so much over there. That's something I would need to play with. But the thing that is, and so there's multiple ways to achieve that, right? Your regular renderer does it during its process of rendering, right? It's got some loop where it's like, oh, I shot a bunch of rays all over my scene, and then I compare like the contrast of one pixel to the next, because it's done a version of the image now so we can look at it, right? And these ones are really contrasty, so I'm just going to shoot lots more rays, you know, into those pixel regions until I converge on something that is okay. Like that's your normal way of thinking about anti-aliasing in a renderer. We can't do that, but we can, because it's real time and it's not a ray tracer. But we can jitter the image around by changing the camera frustum. Like I'm telling you, this is ancient history. The first thing I saw do this was Lightwave in the 90s, and then Animation Master did it also in the 90s, because in the ancient days people didn't really know how to do it properly. And the great thing about it is people abandoned that because it was too slow. It was dumb to render your image like however many times, 32, 64, like, you know, 128, like however many times you were rendering your image, right? It's dumb to do that, the whole image multiple times if you didn't need it. It's much more efficient to choose on a pixel by pixel basis how much you're going to oversample, right? But when we have a real-time image, even, like, this was 256 samples here. Yeah, I mean, it took a little while. It didn't take that long because it's all real-time. So, essentially what this system does is to render the image, the entire image, multiple times with the camera frustum in a slightly different place each time, like within the range of like a single pixel, and then average them all together.
Everything old is new again.
Everything old is new again. And if you really want to get a sense of like how this differs from like, you know, a regular one, like take a look at this, and like it's like, yeah, this is reasonably smooth. If I change my subdivisions to 1 and accumulate the frame, now you can see that like this is just beyond ugly, right? Like this is like super, super aliased. And that's what just generally comes out of UE. But here's what is a very nice feature of this. This is actually really, really nice. It means you do your compositing before your anti-aliasing. So the normal problem that you have doing this sort of thing is you render out a bunch of passes and they are anti-aliased, meaning that, you know, pixels have, you know, like you know, I mean, as an example, right, and then things don't match up. Because like a depth, say you have a depth image, and say you're going to use it in Nuke, right? Well, here's the problem with your depth image: you can't anti-alias it, because if you anti-alias a depth image, you're not creating transparency; you're actually smoothing out the depth itself, right? If you were to blur a depth image, essentially that's what it would do. And I mean, anti-aliasing isn't a blur exactly, but it would have the same effect, right? Your depth would now be inaccurate, and you get all kinds of weird artifacts on the edges. But if you don't anti-alias your other passes, then you don't really have any anti-aliasing, and you can't really do it after the fact and have it look good. So there's all of these like awkward techniques that people use to try to sort of deal with the issues at the edges, and like, you know, sort of, you know, I mean, you can do it, right? People do, but it's all kind of awkward. On the other hand, in the context here where the anti-aliasing happens after the compositing, you can composite with depth and it's fine, right? Because you're not worried about like, oh, I mean, everything always matches. You know, a given pixel always has just one color value. It doesn't have any transparency, and it only has one depth value. And you can just sort of like do stuff, and you never have to worry about things mismatching or dealing with weird edge issues. So it's like doing this with a cumulative anti-aliasing sort of after the fact on your entire composite, because what it does is it renders the whole composite and it does the whole comp for each accumulation and then averages them all. It's really, really, really nice. It's something that I wish I could use in other contexts. And here's the other really cool thing. You could use this to do transparency. Because, of course, the other really significant issue with something like this is, how do you do transparency? Well, transparency is a huge pain in real time, right? You can't do what a ray tracer does and just say, well, that's fine. This surface, a ray is allowed to go through, and you probably do stuff to it, as you know, when it contacts the surface for, you know, purposes of simulating like any number of things. Probably, you know, like maybe you scatter some of the rays and not others, and maybe you bend them so that you do, you know, refraction, like any of the things that you might do, right? I mean, all of that stuff is actually can be fairly complex in terms of like trying to do a real simulation of light, but it is at least sort of has that conceptual basis. You're allowed to have rays go through things. Unreal, of course, like all, you know, hardware rendering, well, that's not true. I mean, you can do hardware ray tracing now, but I mean, you know, as conventional hardware rendering, does not, you know, it has a Z buffer, right? And the Z buffer can only have one value per pixel. You can't, for instance, because I don't think this would work performance-wise, you can't do something akin to like deep images or something like that. You're basically stuck with the idea that you have one value per pixel. So how are you going to do that and make transparency work? Well, what Unreal does normally is it does some trickery. It actually does multiple renders and comps them sort of behind the scenes. Like that's how transparency actually works in UE. Kind of. I'm oversimplifying a lot here, but it is doing a trick, right? You know, I mean, it may be that it doesn't like render full images in comp. It may be that it does that on a per pixel basis. But either way, the point is that your transparent object is not using the same Z buffer as your like regular opaque objects, which is all kinds of super awkward though. And you can get artifacts out of it, and it's like the kind of thing that there's not, I think, like a good comprehensive solution for. In general, there are just solutions that work well enough for various purposes, right? I mean, it's not like you can't do transparency in Unreal. People do all the time. It works quite well in many circumstances, but it's not like sort of a comprehensive thing, and it's very unclear how that would work in the context of this kind of compositing, sort of real-time compositing environment. I am fast running out of time, so let me do something real fast. I am going to throw in, wait, what did I do? Why did I, yeah, that's not what I, stop that, stop it. There we go. I'm going to throw in a sphere. No, I don't want one of those. I don't want a solid geometry thing. I want a basic sphere, which is just a mesh. There we go. Here's a sphere. I'm going to put it somewhere useful. I'm going to make a quick shader for it. Material. This is going to be a little bird material, so I need this one's blend mode to be masked, and I need it to use material attributes, and I need it to not use tangent space normals, and then I can go bring in a little bird thing. Right. I need the material function. And I'm just going to have this be white in color, but I'm going to plug something else into mask. So it's going to be white. That's going to be its color. And the mask is going to be something else. I'm going to use LB accumulated transparency. Plug that into mask. It needs an alpha. And to do the alpha, I'm gonna, you know, I'm actually just gonna use like a simple gradient, so I'm actually going to get text coord. Because if I grab one of the values off the text chord, that can perfectly well be like a value that, runs up the sphere or something. It's going to be U or V, whichever. So I need to split this. So I'm going to say, what is that, break? Yeah, break flow two components. I'm going to try putting the R in alpha. And let's see what I get. Yeah, you can already see it's doing something, what it's doing. So if I throw that on the sphere, its preview is to use dithered transparency. And actually, I do want to use the other one here. So that it's like from top to bottom. Yeah, there we go. So if we look at our, where's the LB comp here? Well, I thought I changed that so that instead of, it was in the other direction. Maybe this is, what the, no, I really thought that I did that properly. What's going on here? Oh, it's getting lighting that I don't want it to get. That's what's going on. I do not actually want it to be getting any lighting. Yeah, let me think about this. I want to omit it from the lighting pass, so I'm going to... I don't really want to deal with that right now. There's a fairly easy way to omit it from the lighting pass. The reason why it's getting this is because it's getting the same shading that she is, right? So it's getting like a two-tone. And I don't really want it to have a two-tone right now, but I don't feel like splitting it out. You could split it out into its own pass. It wouldn't be a big deal. But I don't have time right now because I have to leave in like 5 minutes. So what I am going to do is to say, look, here's some transparency and it looks all dithered and weird. However, what I can do when it accumulates, it's going to try to converge that on something. So watch this. So if I accumulate this image... Oh, I actually had it only do one. Let me go back to 8. That's 64 of them. Yeah, see how it jitters that around? So that it gives you a much cleaner image. Now, not perfectly clear. So there's an alternative way of doing this. And it is called slicing. So I am going to tell it... Oh, no, that's actually a bool, not a bool. Is that B? No, it's not. I'm going to give it a static bool, and I'm going to say use slice transparency. And it's going to recompile some stuff. And let's see what happens now. See what it's doing there? Now, well, you got some weird artifacts here, I think because of the way it's also using a two-tone on it. But what is worth noting here is that you can see her arm through it, and yet the transparency is fairly clean. So I would not like there's some stuff I need to figure out here about like the way the two-tone affects it when it's doing the slicing. But essentially what that does is to slice the thing into little bits, so that at any given render, you're only rendering like a little slice of the sphere, but then when that gets accumulated, it turns into the whole sphere actually, and it's semi-transparent from the accumulation. So artifacts aside, this might not be the best thing to put a two-tone on, or at least not this kind of two-tone. This methodology works really, really well.
It's kind of interesting, Raph. We were talking earlier about how rigging is a kind of programming, but riggers often, a lot of the tools for rigging don't quite have the tools.
Right.
That the regular programmers would do, and it kind of forces people to kind of find hacks, to kind of find workarounds. And it's kind of interesting watching you do this because, of course, I'm not a rigger, I'm a programmer, and my inclination, if I wanted to do things like this, would be to go mess around with the C++. And it would be to go mess around with the guts of the renderer. But in some ways, it seems like you've come up with some stuff here that would actually probably be pretty difficult to do that way. It's sort of like you have a little bit of a rigger's advantage almost in approaching this.
Well, it's an interesting balance because, of course, what I'm doing here, and I've always known this, if you go back and look at my early blog posts on it, it's basically about how evil this whole approach is, because everything I'm doing here is such a hack.
Oh, it is. I mean, that's why I would kind of recoil from it. To be
offense, I mean, reasonably enough. I mean, that's where all the performance issues come from. It's from the fact that it's a hack. If you wrote a renderer to do this thing, it would all be super fast, right?
Sure.
Like, no, this is because this isn't something Unreal is supposed to do. So it's an interesting case because I think that you can get a lot of advantages from just sort of like figuring out your way around problems. And a lot of good things can come with that. But the problem is, once you've done that, at some point you need to pay off that technical debt. And rigging as a whole never has. And that's sort of the problem. It's sort of like being able to get to a point where you can do some meaningful stuff with what you have at to hand is really valuable. But it's really going to come back and bite you if you're not careful. And that's sort of like why Little Bird, though it's incredibly powerful, is also really troublesome to use in a lot of different kinds of production. Like it's basically, that's exactly the reason. So it's like, I mean, you really need both of those things. You need to be able to go and hack some stuff together, because otherwise it's sometimes very, very difficult to even have the ability to make progress, right? But then you also need to go actually figure out how to do it properly if you want that to actually be like a viable long-term solution.
Sure. Steph Devs, by the way, says, which is why I'm keen to write my own toy renderer, all the flexibility. Which
yeah, I mean,
can sympathize with.
I also really sympathize with that.
Probably the first, like, sort of fairly good-sized piece of code that I wrote was a software renderer back in the days when software renders, it was right on the borderline of when software renderers were still actually a thing. It was just as hardware acceleration was starting to come in. And it was a very interesting exercise. I got better at assembly language because back then it was pretty necessary for that kind of thing. And it got me, I would say it got me my job at the Vision Lab, actually, Raf. That's why they hired me there.
Yep.
But yeah, so I highly recommend doing it. It's pretty educational.
Yeah. So anyway, now I absolutely have to go because I actually have a call I need to get on.
Okay.
Well, thank you very much. That is what my life is like. But
this is pretty interesting stuff.
Yeah, no, it is. And like I really look forward someday to A, using this in more productions that are appropriate for it, and B, figuring out how to make this something that's going to be viable for more productions. Because it absolutely would be possible to do. I think it would be really hard to do it for UE without Epic's assistance. But absolutely, like, this is sort of what I think the future should look like for this kind of production, right? For stylized production. The whole, like, even if you're rendering stuff out of UE and then taking it into Nuke or whatever, like, yeah, that's better than doing, like, traditional offline rendering because your rendering is faster, but it's still, like, a whole round trip with a whole bunch of stuff. Right, I just want to be able to always see what something actually looks like. Anyway, thank you guys.
Okay.
Like and subscribe.
Thank you very much.
Tell all your friends they should come watch our streams. And I will see you next time.
Yep. Thank you very much, everyone. Bye bye.
Bye.